Yeah, hi. So, hi, it is more, a day, right, for you?
Yeah, it's 11 a.m. here on the US East Coast.
Okay, okay, nice. It is evening for me. So I'm really very happy that you joined my podcast. So though you don't need any introduction, but still for my audience, I will be giving a very brief introduction. So he is Hank F. Korth, and he's the writer of the famous book database management systems and many other book and research areas. But I remember with that book because that was my favorite book when I was in college. So, yeah, Hank. So, yeah, how are you doing?
Oh, very well, thank you.
Yeah. So, should we start the podcast?
Sh- Certainly, I understand
Sure.
you have some questions, so go right ahead.
Yes. So I'm really happy that I'm getting this clarified from you, who is a pioneer in this particular field. So my first question will be, since you are doing research and all of these things in this field for long, so I would like to understand what was the most significant theoretical or practical challenges that RDBMS solved basically? And what was the problem before that? If you can give some examples of those,
Okay. Yeah,
early days war
certainly.
stories.
Actually, I'm going to take a step back and look at, computer science research
Yeah.
generally and what
Yeah.
does it contribute? And kind of
Mhm.
the one word answer there is abstraction. When I started in computing, I programmed toggling binary instructions with switches. Obviously, a programming language, even an assembly language, is a step up in abstraction, and we've gone way up from that.
Mhm.
And that is what computer science over the years has been about, contributing larger, more useful abstractions. And that's what relational databases are about. So before Ted Codd's paper, there were data models, but what they were really is an abstraction of the way that developers built database systems. Ted Codd took things up to a higher level of abstraction, paid no attention to how it's implemented, and just said that a database is a whole bunch of tables. And then having all these tables, we have some very high-level operations on these tables, and then developed a whole theory around that. This was initially not well received and was viewed as being totally irrelevant to doing anything useful. But as things developed, it turned out that not only was it a useful abstraction, but it drove new technological development. And the reason is that separating the way we view databases and the way we build them gave us the possibility to design databases for performance, have automated query optimization, and do all of that without having to make that visible to users of the system. So that abstraction is the real contribution of relational databases. Then everything else followed from that. The higher level languages, query optimization, automated database design, various clever ways to retrieve data, access methods, indices, hashing, join algorithms. All of those things were enabled by that one key contribution.
Okay. Nice. So, this is just out of curiosity, like, which are the organizations maybe that time who, adopted these concepts early, and who were maybe opposing for the same?
I mean, it's too many years back to replay the debates at this time, but instead I will stick to the advocates. And obviously, the theoretical community latched on to this concept and made some very fundamental contributions.
Mm-hmm.
On the more practical side, there were efforts to develop database systems based on the relational model. Two of the biggest were at University of California at Berkeley, the Ingress project, and then at IBM Research, the System R project. And those two contributed a lot of the fundamental ideas that turn the relational database theory into true practical usable systems. And there's a huge stream of things coming out there. Both organizations publish their work. And so, in fact, the System R research probably had more research impact in startups like Oracle than initially inside IBM, although over time it created, ultimately the IBM DB2 product and all kinds of other products within IBM as well. And the Berkeley effort generated a series of startups, first based on Ingress itself, but that, of course, spawned the Postgres work, and we still have Postgres in wide use today.
Yeah, nice. And this is also out of curiosity, if I may know, what was, according to your experience, like which database you used, at first, or was it a database or something else like punch card or something like that?
Oh, well, I do go back to the punch card and paper tape era, and calling that a database is really a stretch. I mean, then what you had, if I describe it in terms of modern terminology, a bunch of files and programs to operate them. Okay, reality was, a bunch of card drawers with stacks of cards and software to manipulate it. So, long way from that.
Okay, okay, got it. So, my second question will be like, in modern days, as we all know, when NoSQL data lakes are getting popular, how much importance this data modeling here diagram still has or will have? Like, what is your opinion, if you can
Okay,
enlighten?
couple of different comments there. One is that for all the discussion about unstructured data that
Mhm.
motivates modern concepts like, data lakes, etc., there is still a lot of structured data. And where you have structure and can exploit that for efficiency and performance, you definitely want to do that. And so there's a role for a mix of technologies here. But where you specifically mentioned, for example, entity relationship design. Yeah, entity relationship design is about taking the kind of database design that those of us working in databases would appreciate and relating it to something that those in the enterprise who are not technical can appreciate. So because ER design is diagrammatic and extremely high level, it's a way of validating what we're developing in our database versus what those actually living in the enterprise do. And that issue of mapping business needs to our technical solution is very much still with us. And while the tools and methodologies will evolve over time, the basic concept there hasn't gone away. And it's actually extremely important. Because I think too often those of us in technology develop a solution and then look for the problem.
So, I'd like to understand, like, what will be your opinion then on this? Like, if we have data, like, if people are deciding on whether it will be, schema on a write, we should define the schema, or maybe just load as is, and then we will do schema on read, or we will go ahead and do the modeling part. What will be your approach, or you think should be the correct way of doing it? While storing the data, we should do all these things prior hand, or you should go with the flow?
I mean, I wouldn't say you say, the correct, which
Hmm.
means there's one and only one approach. And I'll
Hmm.
go back to my earlier comment that step one has to be understand the business problem.
Hmm. Hmm.
And, if my business problem is simply managing debits and credits in a bank account,
Hmm. Hmm.
that is very structured and static. On the other hand, if I'm doing something that is a very complicated design process or the information for some AI model,
Hmm.
I then have something that is much more dynamic and changing. And so the database designer of today, stated in broad terms, is mapping all of those things together, choosing the right thing in the right place, and thinking about how the needs will evolve. And that latter part's something we've been very bad at. Infamously in the early days, nobody believed their code would last beyond 1999. And so two-digit years were more than sufficient.
Mm-hmm. So, my third question will also be in same line. Like nowadays, we see a lot of controversies between normalized data architecture versus denormalized data architecture. Obviously, whereas from from the time when I belong, we read these database management concepts books, right? And there we learned all this boycott normal form and all of this normalization model. We grew up with an idea like wherever we can do normalization, that is better. But while working in industry, working with the data warehouse and all other analytical things, we also got introduced to that denormalized architecture, and now it is getting popular nowadays. So what will be your opinion on the same?
Well, that was even popular in the old days. So you would design a normalized database, but then denormalize for performance. It might be done by a materialized view. It might be by explicitly, denormalizing where that was advantageous. And it goes back to mapping the implementation to the business needs. But then in terms of looking at data, where data has structure, a normalized design may be, a more understandable design in certain applications. Um, on the other hand, there are cases where you could imagine just talking about the things in your information system and not worrying about the explicit connections and having them inferred automatically by the system. The whole range, is certainly applicable. So, normalization is a useful tool. It's not necessarily, the ultimate in all cases, but because it allows us to talk about organization in a rigorous, formal way, that's certainly valuable. And, a lot of databases come from strange sources. And then when you want to say, well, this spreadsheet that you're just dumping into a relational database is badly designed. Normalization gives me a way of saying, and here's why it's a bad design. And here's why these changes might be better. So definitely has its place and its role.
Yeah, yeah, definitely. So I before going to the the most important question, I think how your focus shifted towards blockchain. I would be interested into one more thing. Like you did a lot of research with a distributed database management system, right?
Yep.
And I would like to understand, according to your opinion, your experience, what are the biggest challenges while you are working in a distributed, database systems? What is the biggest challenge?
Well, in the oldest of old days, and I may be the only one listening to your podcast here who is old enough to remember, but you know, there are large mainframes that sat isolated, and that
Mm-hmm.
was all it was.
Mm-hmm.
Um, The movement to distributed systems came from two forces. One is the business force of, I now need to have data near where it's used. And so a single enterprise now simply needed to have multiple systems in multiple locations for that reason, but then wanted to link them together. And then the second force came with the advent of improved networking, both the internet broadly and the Ethernet more locally, to allow us to move from a mainframe-based architecture to more of a multi-machine architecture, even within a single location. Now, as soon as you move to distributed systems, there are more challenging questions of coordinating transactions, reaching decisions. And so as a researcher, that was a natural direction to move. And since you did, mention the word blockchain, I'll wait till you ask the question to go there. But a really important point in distributed database system research is that the bulk of the research was still based on a single organization owning the whole thing. So you could imagine a single DBA as the overarching control over a wide distributed network. But then something else we looked at in that space, which some called federated databases, we called multi-databases, was the idea of separate institutions trying to coordinate their databases. Like imagine a set of airlines that are able to make reservations in each other's systems. They still control their own systems, but they are now also customers of each other and might like to run transactions across their systems. So here you now no longer have a central point of control. And managing transactions in that environment is extremely challenging. We spent a lot of time in the latter part of the 80s and early 90s working in that space. So that was a first move away from pure centralization.
What is I mean, if I talk about two-phase locking or concurrency control or acid compliance or security, uh, I mean, according to your opinion or your research, what is the most challenging thing when we talk about distributed systems?
Okay, well, the biggest issue in any kind of distributed system, database or not, is the fact that an individual machine in that network does not have exact perfect global knowledge. And one of the biggest challenges in designing algorithms for this is that you think you know everything going on, and that's fine, but you have to ask, what does this system know and when does it know it? And
Hmm.
so the issue of distributed knowledge becomes a fundamental problem. I mean, you mentioned something, as straightforward as two-phase locking, but how do I know whether I can grant a lock or not?
Hmm.
We have, if locks can be granted in multiple places,
Hmm.
conflicting locks could be granted. And so
Hmm.
you have a mix of distribution of the systems, but some degree of either centralization or coordination of the
Hmm.
underlying functions. And that basic idea runs across everything you do in any kind of distributed computing.
Yeah, yeah, definitely. So now my next question will be you invested a lot of time in RDBMS systems, right? And then you shifted your research towards blockchain. So what inspired you and how this blockchain is data storing and handling in blockchain is different from the RDBMS, or what are the similar things, if you can enlighten us?
Okay, I mean, obviously blockchains store data, so I can
Mm.
claim it's a database and say I didn't change. But so the reality, how did I get there? Um, I mean, I've always looked at computer science generally, reading about old work on e-cache and cryptography and so forth. But the impetus was actually students wanting us to have a course here at Lehigh University in blockchain. And I said, well, okay, I'm working in database. It's not that. I'll see if anybody's interested. Nobody was. So, okay, I will go teach a course. So I didn't know what a course should look like. And what I did was take advantage of the fact that we have at Lehigh, besides our computer science major as a pure CS degree, we have another computer science degree, also fully accredited and so forth, that also combines a business degree with the computer science degree. And so, with that in mind, my first blockchain course was a little bit of the basic tech, but then also looking at applications, policy, yeah, regulatory issues in the space. And I found that we had some graduates of Lehigh in some interesting places. Most interesting, the premier information and conference organization in blockchain, CoinDesk. The CEO was a Lehigh alumnus. A cold call got him to agree to be a guest speaker in the class. We had the first Subway restaurant to accept Bitcoin, Lehigh alumnus. Got him. Um, since we had a strong business program, we had connections with the big four accounting firms. They were starting to think about this. So we brought in a lot of interesting people. And then another, fun coincidence was as we started doing projects in this space, we discovered that one of the major contract development firms in the space, ChainSafe, their CEO grew up in the next town from Lehigh, Allentown, and he was got interested in our work. So we started to develop, a bit of a community. And I said, okay, let me go also do a pure computer science course. Tried to figure out what should be in there. So that was the start of it. And then I started to see the research issues in this space. And so we started getting research underway. And this thing has exploded since. We now have a bunch of courses, graduate, undergrad, in business as well as in computer science. We have a wide variety of research programs going, and a bunch of graduates of our program who are doing some really cool, influential things in the blockchain space. And the we have a website for this. Fairly easy to get. It's blockchain.cse.lehigh.edu. So blockchain, easy enough. CSE is for computer science and engineering, my department. Lehigh, the university, LEHIGH.edu. And up on the tabs there, we have our various friends who have come to speak and sponsor projects, our alums, our courses. And in recent years, we've had some absolutely fantastic people involved with our program in terms of speaking in a class, providing research support, leading capstone projects with students, and of course, hiring our students. So it was just a steady progression since the first class in January of 2018 to where we are now.
Yeah, nice. I noted this website. I will definitely check it out and learn something from there because I'm very new to this field, blockchain. So I don't have much knowledge on it, but it is really very emerging technology. So I need to learn that.
Well,
So
I might take a moment before the next question then to
yeah,
tie this to databases. Okay.
sorry.
But yes, we'll tie this to databases,
Okay.
right?
Yes.
Yeah,
Yes.
blockchain store information.
Ha ha ha.
But you know, blockchains fundamentally are about establishing trust between untrusting parties.
Hmm.
Um, and so that's a kind of distributed consensus,
Mm-hmm.
something that we had in distributed databases, except now we have untrusting parties. Earlier I mentioned the multi-database idea, multiple airlines who only partially trust each other. Here
Mm-hmm.
we could have true total mistrust and still need to build an incentive system to reach consensus. So consensus here is, in some sense, a database style problem, but with very different assumptions.
Mm-hmm.
And query processing here, again, works in a very different way um, because we now have independent pieces of code that are deployed on chain and running.
Mm-hmm.
And it's a very different execution environment than what we're used to. But of course, ultimately, at the end, it is a managing and delivering of information.
Okay. So, one question coming in my mind because I mean, as per my very little experience, when I worked for financial companies, I see in RDBMS we have a lot of this deadlock prevention, locking mechanism. We make it asset compliance, transaction processing. We do everything and security mechanisms are also there. Just wanted to understand, and they were running for decades. They were like working fine for the, like, financial organizations, or many uh, systems where security is a very big constraint, trust is a very big constraint. So what makes blockchain so different that it is adding this more trust? Or I mean, if you can, I mean,
So,
elaborate.
yeah, so let me elaborate on trust. So, in the traditional financial system,
Hmm.
trust comes from trusted intermediaries,
Hmm.
banks, stock exchanges, brokerage firms, etc. They are highly compensated for that. Even something as simple as going to buy a cup of coffee with a credit card. Um, a big chunk of that transaction goes to the banking system, and that's the price of trust. Now, blockchain technology, by turning that trust provision into something that is crowdsourced, um, creates a lower cost way of establishing trust and also a way of establishing trust that anybody can join. In the traditional financial system, I have to be let in. And as you may know, there are a huge number of unbanked people globally, even in highly developed countries, like, say, the United States. So unbanked means you don't have access to credit cards, debit cards, checking accounts, ATMs. Your savings is cash under the mattress, which is not a very safe place for your savings. So what blockchain allows is anybody with a rudimentary smartphone to join, or computer, and now you have a place to save, to get loans, and to develop some kind of financial capability. So there's a global openness to it. And then in a more established setting, the payment rails are, faster, cheaper, more open, and not subject to censorship. And this is something that is now very much emerging globally, but particularly in the US. The US recently passed legislation, something called the Genius Act, passed by a bipartisan majority in Congress, signed by President Trump, that creates a approved framework for cryptocurrencies pegged to the US dollar. And this is now a first step to take these payment rails and make them available to traditional finance operating on the US dollar and opening up a new avenue for global financial competition. Obviously, other nations and their central banks would like to compete here, and this is now giving added impetus to dollar dominance. And so, a whole thing happening there. And then in payment systems, we can now take blockchain payment rails and bring them into the traditional finance space, where many firms are now looking to issue their own stablecoins. So there's a merger of these things coming, um, with, a different form of trust, a more open system, a lower cost system. And the openness is really important, because in a banking system, governments can whisper to the banks and deny access to organizations whose philosophies they don't approve of. And such things have happened globally. I won't enumerate here, but you can look it up.
Yeah, sure, sure, Hank. So that is also bringing one question to my mind. This might be a stupid question, but if it is crowdsourced and if anybody can join, and also in blockchain, we don't have any centralized monitoring, right? I mean, it is decentralized system. So isn't there a also a risk of someone is maybe mining fake currency, or someone is doing some financial fraud, anything like that? And also there is some financial organizations are moving towards it, some are not, they are skeptic about it. So what is your opinion on this?
Okay, I mean, first of all, we have to look at where fraud happens. The biggest medium for fraud by a huge margin is the US dollar. And so if you're going to ban currencies where there are fraud, the US dollar needs to go. And then right after that, the euro, and you see where I'm going. So there are always scammers and fraudsters, regardless of medium. Now, a blockchain has a huge advantage in fraud detection because public blockchains are public. And so that means everything's out there. The only thing that isn't immediately public, if I create a crypto wallet, is the mapping between that wallet address and me, the person. But the moment I use that address to interact with the real world, we've got a connection. If I pay you, let's say Bitcoin, now you know my wallet address. You can look on chain and see my entire financial history
Mhm.
and monitor my financial future. And so it is very easy to conduct, I shouldn't say very easy, but very feasible to conduct um, investigations. So
Uh,
the real challenge we face is taking that vast publicness of blockchain and providing a sufficient privacy structure on top of that to
mhm,
deal with the fact that just because you and I split the cost of lunch, I don't want to share my financial history with
mhm.
you. Um, but yet, perfect privacy could allow me to do something nefarious like, fund terrorists or something like that. And there's technology that does that. Um, it's based on cryptography, a thing called
Yes.
a zero knowledge proof,
So,
where I prove to you that I know something without telling you anything about the thing I know except that I know it. And this can be a way of having regulatory compliance, privacy, and blockchain efficiency.
okay, okay, got it,
That's the
got it.
big appeal.
That's interesting. So my next question will be, so Bitcoin and cryptocurrency, obviously they are based on blockchain, but what are the other real world applications which are currently based on blockchain, or where blockchain has a huge potential?
Okay. So people go directly to Bitcoin. Bitcoin has a limitation in that the scripting language is limited.
Mm-hmm.
Other chains, I mean, the second biggest is Ethereum, so I'll focus on Ethereum, has a Turing complete language, which means that I can build a whole business that operates on chain. So anything you can do in Ethereum. Now, obviously, creating a currency is one application. Enterprise information is a huge one. Anything that is business to business can be done on chain, where you now have open access. You have this technology to allow privacy where you need it. And supply chain is certainly a huge example there. Another example is tracking the provenance of product, so avoiding fraud, copyright violation, and so on, that you can track products from source to ultimate sale. So there's another example. Um, Other examples can be in the area of corporate finance, where certain disclosures are required, and these disclosures can be done again with some cryptographic degree of privacy, but on-chain publication. I mean, you could in principle have continuous audits. I'm not sure people would want that, but there is an ability here to put information out quickly, efficiently, at relatively low cost. And in a business setting, it becomes easy for businesses to join various business to business activities without having to have complicated agreements. The terms of relationship are in code, and that's out there for everyone to see.
Yeah, nice, nice. So, how do you think like this So we have a big thing called data governance and data security, all of these things, right, in our traditional data management scenario. Now, in case of this blockchain, if it is gaining popularity more and more, so how this uh, data governance approaches will change? Like who will govern what and how it will get split? So.
Well, for some of this, in saying who will govern, there's an implicit assumption of central control. And the real beauty of blockchain technology is that you can go fully decentralized or have some centralized services or services that are governed by a particular group, like holders of a particular currency.
Mm-hmm.
And so governance becomes a continuum that can be tuned to the particular application in question. And when you talk about, say, management of data, um, that used to be done, in-house, in a big machine in the basement. It's moved, of course, in more recent years to cloud services that are, again, large and centrally managed. In the blockchain world, there's a concept of decentralized storage, where if I have some extra space on my machine, I can make it available as a service in this decentralized storage system. And if I have data I want to store, I can submit it for storage. And the system spreads the data out encrypted over storage providers with enough replication to ensure data survival. And so you can have a decentralized storage ecosystem with everything, fully encrypted. And then for this data that I'm storing, I can govern it however I want. It's my data. Yeah. And so what you have here then is the full spread of things spread out in a decentralized way, but still ownership of data by the individual, person or organization who owns it. So it's a new flexibility in how things are actually deployed. That can be cheaper. It can be, in many ways more reliable. If I run my company on some cloud provider and that cloud provider, for whatever reason, does not want to serve me anymore, I've got a problem. If the crowd is serving me, I have much more confidence of continued
Mm.
service.
Yeah, yeah. So, I would like to understand, according to your opinion, what might be the cons or if there any cons of blockchain system? We discussed all the pros, right? If there is any
Well,
con.
probably, the biggest flaw in any system is people. When we talk about cybersecurity generally, right, the number one thing is the password on a yellow sticky up on the monitor. You know, phishing. Yeah. And these human things are, always a problem. And in the blockchain world right now, I would say that in general, the user experience is very poorly developed. You know,
Mm-hmm.
if I have a blockchain wallet and I use, wallet software like MetaMask, it is not very user friendly. And if I'm trying to pay you and I make a typo in your address, it goes to some non-existent address and that cryptocurrency is gone. Blockchains are immutable. I have now just burnt it. It's like lighting a match to cash. Now, there are ways of managing these things with better user interfaces, social recovery for keys, and I think as we see broader usage by the populace as the stablecoin revolution starts to hit, there will be more development of a better user experience. So that's certainly, an area for work that, techies in the space don't mind it. We're fine. But that will, definitely need to be broadened. And another thing about openness is that it's open to everybody. And so anybody can go, create, uh, some meme coin, you know. So I could just go put Hank coin up there, and try to sell it to people and then take the money and run, you know. So, an awareness of where scams can happen. That's not unique to blockchain. You've got a cell phone. you get all kinds of spam calls and text messages that are trying to fish from you certain personal information. Um, and so in any domain, you have to be careful. And blockchain is no exception there.
Yeah, yeah, definitely. So, just according to your first example, right, where some address was incorrect, and because blockchain is not like mutable so easily, so that currency is gone. I'm bringing that perspective only. So, in our traditional RDBMS systems, right, we have processes for transaction control, we have asset compliance, we do rollback if everything is not reflected properly in all of the nodes, right? So uh, how this so basically in blockchain world, how this happens, this rollback, because what you said, I think, I mean, if we have this kind of issues in our normal RDBMS, we can just take a break glass access or admin access and delete the record, update the record, or do a total rollback of some transaction which happened. So how this is handled there?
Well, I mean, in a database system, you have rollback up to transaction commit. Yeah, so rollback for deadlock, rollback for transaction aborts, et cetera, et cetera. Same thing in blockchain. Can run a transaction, divides by zero. They use the term revert in the blockchain world rather than rollback, but the same idea.
Okay.
But then once a transaction is committed, again, in blockchain speak final, then it's forever. Um, so the only difference here, it's not a question of commit or finality, but that in a database, we have this overarching administrator who can overrule transaction commit.
Mm-hmm.
Um, in a public blockchain, we don't have that. Yeah. Now, I mean, there have been famous things like the Ethereum DAO bug where there was a fork to make some changes, but that's a digression for our purposes here. Um, but so the basic idea of transactions exists in both systems. And the idea that, well, some things go wrong. We have that in the traditional world as well. You talk a lot about asset systems. Of course, the most popular form of concurrency control for transactions is snapshot isolation, which does not ensure serializability. So the real world has made some compromises there. The real world also makes compromises in terms of what correctness really means. I mean, simple example. I go and book a series of flights for some business trip, whole bunch of, flight here, there, someplace else. You now come along and find a flight full because I took the last seat. But I then cancel my trip, which is kind of like a transaction abort. You saw the effects of my now aborted transaction. Do you have your reservations all canceled because mine canceled? No. We accept certain things rolling forward to correct things. And so also in an immutable blockchain world, I can submit new transactions that change things, you know, that may, alter the state back to something that was before, but I do that through a new transaction rather than doing it through, rollbacks and cascading aborts, etc. So the real world transaction model is a whole lot more complicated than, you know, the first coverage in a textbook.
Mm-hmm.
That's
Yeah,
true in both cases.
yeah, yeah. One more question I am having, that is, I was going through history of database evolutions and all. So basically, from punch card, magnetic tape, I'm leaving them. So from RDBMS, where schema was very much well defined, then we came to this NoSQL databases, distributed systems, and now blockchain. So because you are in this active research field, what next? Or these things will sustain, or something new research is already happening?
Oh, there's always stuff happening, and I mean, when you talk about what's happening right now in research, it's hard to have that conversation and not mention AI. And in some ways, we're seeing a repeat of things that have happened before. Um, what we have now with these magnificent Gen AI systems is basically a centralized source of truth. Yes, after I get an answer from one of these large language models, I can ask further questions, like where did that come from? But it's all coming from that one source. Um, Now, there is an emerging model of AI based on decentralization,
Mhm.
where instead of having, a large language model that needs these, massive data centers with, zillions of GPUs, you have small language models that are more focused and therefore can run on much smaller hardware. And then the possibility of having collections of these that supplement each other, compete with each other, overlap with each other, and then look for a way of weaving all of that together into a unified, usable whole. Okay, now compare this to traditional databases and blockchain. My corporate database is a single source of truth. That single sourced model has evolved to a decentralized model, where we collectively can still manage information, run enterprises, and so forth, but have gone from centralized to decentralized. Um, there's work going on, and we do have a project here in Lehigh in this space that is looking at the BitTensor chain that's backed by Yuma. And the idea being that there may be ways of providing these kinds of services in a decentralized service model, where you then have a financial ecosystem to incentivize participants to contribute positively, with the best contributors getting rewarded. You know, again, to the database and blockchain analogy. Instead of a central company that simply writes a check to budget for their database system, we secure a blockchain by incentivizing the crowd to take actions that collectively contribute to the security of the chain. And we're starting to see the very early glimmers of decentralization applied to AI, which has two advantages. One is the fact that we no longer have an LLM in effect owning truth.
Mhm.
But the other thing is that by having this, widely sourced provision of information, it becomes a whole lot easier to explain from where an answer came. And explainable AI is another very important area of research to take the whole LLM concept to the next level. So things keep happening. In some ways, the history of research repeats itself, but in other ways, it's new, and both happen at the same time.
Yeah, yeah. So that brings to my next question. Like, according to your opinion, how AI will change this traditional database management systems or query optimizations, DBA rules? I mean, there are a lot of news in over the internet, right? That these DBA rules will not be there for long. So this will not be there for long. So something like that. So what is your opinion and suggestion to the new maybe database professionals?
Okay. Again, a repeating of history. Yeah. New technology is going to get rid of all these roles, and we'll have nothing to do except sit there and watch it. Um, when we talk about the wide range of information that we talked about earlier, what we used to just call relational query optimization is now a much broader thing of optimizing information management across all its different kinds. So there'll be new roles. But specifically for query optimization, a role of AI there, that's something new. Query optimization can be, fully algorithmic and optimized, but many things turn out to be heuristic because not everything is 100% predicted. Database design also can fit that. There's work going back decades in terms of doing effectively query optimization in reverse. In other words, instead of saying, here's my database design, how do I run this query? Instead, we say, here is my query mix. How should I design the database to be optimal for that query mix? And so the heuristics that went into that, arguably are a form of artificial intelligence. You might view them as being more algorithmic, but there's always been some heuristic nature to things that we do in computing. And this is just a continuation of that continuum, but in a very exciting and new way. So certainly I could have an LLM do my database design. I could have my LLM do my query optimization by giving it all of that information. And you know, that's just a better way of doing certain things. But then, we talked earlier, not all data goes into a relational database. Now, how do I optimize across that richer set of data?
So, this will be my last technical question, and this is like as we discussed about RDBMS systems and blockchain. Now coming to NoSQL databases, vector databases. So, for LLM applications, majorly we use some vector database to store the embedding vectors, right? Which do the similarity search and all. So, just wanted to understand from you, what is your opinion? Can't they use any traditional RDBMS for the same purpose or blockchain for the same purpose? Why? I mean, what is your opinion in this?
Well, uh, if you say can, obviously yes, one can do it. But should one do it? And this comes back to using the right tools for the problem at hand. Um, and so, for many database applications, SQL was viewed as a you know, heavyweight solution, and then NoSQL systems initially developed to just allow some more programmable access. They evolved, and as you well know, the term NoSQL got morphed into not only SQL. you
Yeah.
know. And so there's, a flow there. And you mentioned, vector databases, you know, very different kind of database in terms of the data, but also the volume. And beyond that, the way those vectors are used. And so naturally, you would expect that there would be some different designs, both for storage and for operation. And yes, I can express that as a collection of tables and a collection of SQL statements or relational algebra expressions, but that's probably not the best way to do those things. That said, the structuring concepts coming out of the database world are useful concepts to be employed across various things that we do.
Okay. So basically, it is always the data and the business problem, which is the deciding factor of the right tool, if I am
Yes.
understanding correctly. Yeah, thanks a lot, Hank, for all of this, your great insights. So now we have 7 minutes left, I guess. I would like to understand maybe a little bit your background, like where you always in this education field or research field, and was this your interest from the childhood?
Um, that goes way back. I mean, I am older than the space age. And so we're talking really far back here. The Soviet Union launched Sputnik in my lifetime. So we will go beyond that. But I mean, in terms of job roles, first of all, I have bounced between industry and academia. My first job out of grad school was IBM Research. I went from there to the University of Texas at Austin. I was then the trailing spouse when my wife got tenure and wound up working for a Panasonic research lab in the Princeton area that I wound up directing. And then when priorities changed with a downturn in the Japanese economy, it was time to move. I moved down the road to Bell Labs, which was phenomenal. We had a wonderful database research group within the Bell Labs context until the telecom bust, at which point again it became time to move, and I moved over to Lehigh as a outside hire as department chair. I'm not doing that anymore, thankfully. Department chair is a difficult and sometimes thankless job. Um, but it was a very good experience. We built a nice department here. And so I've been back and forth and not always, purely in academia. Um, it's been fun to be on that boundary between the two. And certainly now working in blockchain, that's an environment where industry is driving the innovation. Um, Academia does wonderful work in cryptography, but a lot of the core blockchain work is happening in startups, in companies, and as a result, students tend to go directly into the job market and not stay on for a PhD and do the traditional academic role. So I've been, back and forth there. And as far as, what were my interests, we have to remember that computers were pretty rudimentary things when I grew up. Programmable calculators. My dad had one at work, and yes, I got to play with that, and he showed me how that worked. So I got an early intro into the idea of programming, and then later working with the PDP-8 where I toggled things in and programmed that way, and data was stored on paper tape. Um, and when I tell students these things now, you know, so you were interested in computer science because of that? It's a very different entry point. But I found the stuff fun.
Yeah, nice, nice to know, Hank. And what will be your suggestion to early, database engineers, data engineers, software engineers? If you can give one suggestion and one of the, takeaways from your early days, which is still relevant. You can give some.
I mean, the number one thing is be open to change and
Okay.
grab opportunity. I
Mm-hmm.
mean, you mentioned at the outset my database book. I didn't set out to write a book. When I got to the University of Texas at Austin, I was working with Avi Silberschatz, and he at that point had a successful book in operating system concepts, then co-authored only with Jim Peterson. We talked about the idea of a database book. Okay, and so I had the opportunity to work with a co-author who was a successful textbook author. So an opportunity like that, I grabbed it. And that's how the titles mesh. Database system concepts, operating system concepts. We kept the same, kind of, theme there. And so that's how Avi and I did the book. But of course, we got, too busy to maintain it. And then later on, we added Sudarshan. He was a wonderful addition. He has made fantastic contributions going forward. And a lot of the good stuff in the later editions is really his work. So, definite shout out to Sud for his role in the book, as well as, Avi, who's a great collaborator in so many things.
Yeah, yeah. And that book was really, really great, I think. And most, I can say famous book, at least in my continent, my country, in computer science engineering. So everybody reads that book, whichever university it is. So that's really great. So thank you, Hank, for your time, your valuable time you gave me for clearing my doubt, and you came here. That means a lot to me. I have no words for that. Thanks a lot.
Well, it's been my pleasure. So thank you for the great questions. It's been fun talking.
Thank you, thank you. Hopefully, we will connect later, maybe
Yes,
in with some other podcast. But yeah,
sure.
and so
Definitely.
goodbye and
Bye.
maybe have a good day.
Thank you. Same to you.
Thank you.